So this one is quite clear. Melting point increases as number of carbon atoms increases. Okay? Yeah, because there is more bonds being broken, it needs to absorb even more energy, and that's why the melting point needs to be higher. Okay, so moving on to the next question. We have this. It's an electrolysis tank used to extract aluminium from aluminium oxide. Pure aluminium oxide melts at 250 degrees. Okay. So here we have the graphite electrode, and then we have the carbon electrodes, and then we have molten aluminium here, and molten mixture of aluminium oxide and chloride. Okay. And then chloride is mixed as an impurity with aluminium oxide. State the effect it has on the melting point of the mixture and explain why mixing chloride is necessary. Okay, so since they mix it as an impurity, right, it actually decreases the melting point of aluminium oxide, because aluminium oxide is a salt. It usually has a very high melting point, and you need to lower the melting point in order to save cost and energy. So you need to understand that this chloride will not be reacting, right? So it is added as an impurity to reduce the melting point. Okay, because there is now less of the aluminium oxide salt, which has a very high melting point, in order to melt it. Okay, so let's write it down. The mixture would have a lower melting point, and this allows the aluminium oxide to melt at a lower temperature and save cost from electrical energy that is reduced. Okay, so now we have to write half equations for the reactions that take place at the anode and the cathode. Okay, let's look at this. So here's the positive and flows. Okay, so the anode and the cathode, right? So the anode will attract the negative anions, and the cathode will attract the positive cations. Sorry. So the cations will be the aluminium and the negative. Okay, the positive will be the aluminium, and the negative one will be the oxide ions. Okay, so for the anode, we will write that the O2 minus, it is in group 6, so it will be a 2- charge, and this is in molten state, liquid. So we form the oxygen gas, and then we also need to know that since there's 2 oxygen gas, and let's balance this out, this will be 2 oxygen atoms. It will actually be removed of these 4 electrons to balance out the charges, right? And then for the cathode, we know that it attracts the positive aluminium ions, the cations. So we have aluminium, which is a 3+ charge in molten state, and instead it will be reduced. So it will gain 3 electrons to balance out this 3+ charge and form aluminium. It's also in molten state. Okay. If you're wondering why is this not a solid state, it's because the temperature is very high, as you can see above, right? So this will be in molten state. Draw two arrows on the diagram to indicate the flow of electrons, clearly label on the two electrodes. Okay. So let's look at the flow of electrons here. So here is the electrode, and you have a line that goes in here, I believe, and this will be negative. So this is positive. Electron flows from negative to positive, right? So you have this going here, and this going down here, right? And another arrow will be the electron flow. It goes from negative to positive, so this is the other arrow. Okay, let's move on to D. What is the volume of oxygen produced under room temperature and pressure when 540 grams of aluminium is produced? Okay, so first we write the overall equation, right? We have aluminium oxide, which is Al2O3, because O has a 2 minus charge and aluminium has a 3 plus charge. So to balance it out, we have 2 of aluminium, 3 of oxygen, producing aluminium and oxygen gas. So let's balance this out. Put 2 here and 4, and 3 here. So we have the number of moles of aluminium, and it will be 540 grams, which is the mass divided by the AR of aluminium, which is 27. As you can see here, it's 27. And then this will give you an answer of 20 mole. So you can see the mole ratio, right? That for every 2 aluminium oxide used, 4 aluminium is produced. So the number of moles of oxygen produced will also be in the same mole ratio. So here we'll have 4, you will produce 3 of the oxygen as well. So 20 divided by 4 times 3 is equals to 50 mole. And hence, the volume of oxygen produced. For gases, as you know, it is the number of moles times 24 dm cube, especially at room temperature and pressure, RTP, right? Which will give me a total of 360 dm cube. So this will be your answer. Okay, let's move on to the next question. The carbon electrodes are replaced at regular intervals. Explain the need of this. Okay, so basically, right, let's look at the electrodes again. So we do know that aluminium is produced there's aluminium produced and there is the oxygen gas produced. So what happens is that there's this thing called oxidation, right? Where the oxygen will react with the carbon electrode that are used, okay? So that is why we need to replace the carbon electrodes, because if it oxidizes the carbon electrode, it won't be able to form and continue this electrolysis cycle anymore. That's why we need to replace these carbon electrodes. So let's write down the presence of oxygen gas reacts with the carbon anode to form oxides of carbon. Yeah, and that is why you are to replace the electrodes. Another way you can write this down is that it will oxidize the carbon electrode and reduce the mass of it, which makes it unusable, which is why we need to replace it. Yeah. Okay, so we now draw a labeled diagram to show how a metal object could be electroplated with copper. Okay, let's draw the diagram. Okay, first let's draw this wire, the very standard one. We have the positive side and the negative side. Okay, and so since this is positive, we will draw this one here, and we'll draw this with another shape, so you can differentiate, right? So this positive, this will become plus, and since this is plus, will be the anode. Okay, and you want copper. Okay, so the anode will be copper. Okay, we can just use copper, and then this has the object that you want to electroplate. Okay, so this will be the cathode, because over here is negative, right? And so we draw the path for this to be in. Please remember that it needs to be properly submerged. Okay, so we need it to be free moving and mobile, and also contains the copper. So we'll make it copper sulfate, and it needs to be aqueous. This is important. And there you have it. The cathode will actually attract these positive copper ions, and hence it will form the copper metal here. Okay, and that is how it will electroplate this object. Okay, remember in this kind of diagram, you need to have correct terminals. You need to label your anode, and you need to label your cathode, and also this battery here, and also you need to correctly label your materials, which is this copper, your object, and also the copper sulfate. Okay, let's move on to the next question. Zinc is extracted from an ore called zinc blende, okay, which consists of zinc sulfide. Okay, the blend is first crushed to powder and then treated by phosphorylation, which is used in the extraction of several metals. Okay, zinc blende reacts with oxygen in the air to produce zinc oxide and the gas, which escapes as a waste gas. Okay, so this zinc blende reacts with oxygen and produces zinc oxide. So explain why zinc blende is crushed to powder before treatment. Okay, remember, if something is crushed, right, or like maybe finely, remember the finely divided ion catalyst, everything, it is actually to increase surface area. So remember, it's always to increase surface area. And now you need to think about why you need to increase surface area. And the reason for this is because there is a higher rate of collision, higher frequency of collision, sorry, as you remember in the collision theory, right? And this will mean a higher rate of reaction. So let's write it down. There's a larger surface area for collision to occur, and hence there will be a higher rate of reaction. Next question. Write a chemical equation for the reaction in AI. Okay, so this zinc blende, right, it's zinc sulfide, and then it will react with oxygen. So let's write oxygen, and this will form zinc oxide and the gas. Zinc oxide and the gas. The gas, as you can see, there's sulfur here, there's oxygen here. If you combine both of them together, it will be this sulfur dioxide gas. Okay, let's balance this out, 2 here and 2 here. Okay, and here. Next question. Zinc oxide is converted into zinc. Zinc oxide and coke are fed into a furnace. Hot air is blown into the bottom of the furnace. Zinc has a melting point of 110 degrees and a boiling point of 900. The temperature inside the furnace is over 1000. Explain why zinc oxide is converted to zinc. Show the equation. How the heat is produced and equation for all the reactions we describe. Okay, so you know that in the furnace, right, what's the most important reaction to produce the heat? And that is the burning of the carbon, or you can call it coke. So let's write it down. Heat produced bicarbon coke. Oh my gosh, coke in oxygen or air. And you know that this is CO2 to form carbon dioxide, and this produces heat, and you can also write that 2C plus O2 equals to 2CO, which is producing carbon monoxide because it is a incomplete combustion, right? But you can write either, so it will give you 1 mark. And then you need to know that zinc oxide is converted to zinc. And how does this happen? It actually by the displacement of the zinc from the oxide, right? So let's say you want to use by carbon monoxide, okay? So you write zinc oxide plus carbon monoxide equals to zinc plus carbon dioxide. As you know that this here displaces the zinc, and hence the zinc is produced. Okay, so give 2 reasons why the zinc produced is inside the furnace is in gaseous state, right? So gaseous state means it is higher than the boiling point, and zinc's boiling point is 907 degrees. The temperature inside the furnace is over 1000 degrees. So let's write it down. Temperature is above 907 degrees, which is the boiling point of zinc, okay? Which is the boiling point of zinc. And also, right, the temperature inside the furnace is 1000 degrees. So yes, this gives you 2 reasons. State the name of the physical change for conversion of gaseous zinc into molten zinc. So gas to liquid, you know that this is definitely condensation, so this is very straightforward. Okay, so now you can see rusting of steel can be prevented by coating the steel with a layer of zinc. Explain in terms of electron transfer why the steel does not rust even if the layer of zinc is scratched and the steel is exposed to air and water. So basically why we coat it with the layer of zinc, and hence, right, it prevents the rusting of the steel. Okay, so this is a relation to your reactivity series chapter, and hence, right, we know that zinc is more reactive than iron, and because of this, right, zinc loses electrons more easily and it will react with the air and water, yeah, instead of the steel, okay? And that is why the steel does not rust. So let's put it down in words. Zinc is more reactive than iron, and hence zinc loses electrons more easily, reacting with the air and water. Okay, so let's move on to B9. Petroleum is a source for many important chemicals. Name 2 industrial processes which must take place to produce alkenes from petroleum. Okay, so this one is referring to your industrial process chapter, and you know that this is actually from fractional distillation which is from the process where you have different temperatures, right? And hence, and that's how you obtain the different fractions from the alkane. And when you have that, you also need cracking, which is to form smaller carbon chains, smaller hydrocarbons from the large hydrocarbon that you obtain from petroleum. Okay, so we have this part, ethene and propene can be converted into polymers. This type of polymerization reactivation, ethene forms a polymer. So this is definitely from alkene to alkane. So we have a lot of small alkenes which combines to form a long chain of alkane, okay, which is a polymer, which is a long chain of alkanes, okay. So this is called addition polymerization. Okay, let's see how you can identify the empirical formula of the polymer from ethene. So you know that ethene is actually C double bond C. So let me draw the rest. 4 bonds each, right? And hence the polymer, when you form this, it will break this double bond to form a single bond, and then it will connect to more of these, right? And hence, let me count, it will be C2H4. To find empirical formula, you need to divide it, and that's why you find CH2, which is the simplest form, okay? So draw two repeat units of the polymer made from propene. Propene, as you know, it is actually this structure, C double bond C, and then you will have an H here, let me erase this, and then you have a CH3, which will be here, but I would not draw that. We have this, and hence this will be multiplied by n in order to form the polymer, right? Yeah, propene is made of 3 carbon molecules. Okay, 3 carbon atoms. Okay, so the repeat unit is actually C, and then you have H here, and then you have the CH3. Note that I do not draw the double bond here because it's already been broken, and I'm drawing the repeat unit. So this is one repeat unit, and then you have the next repeating unit, which will be the same thing, and then it will continue on. Okay, so these are the 2 repeat units made from propene. So let's look at the next question. Most of the hydrocarbons obtained from the petroleum are alkanes. The alkanes are homologous series of saturated hydrocarbons with the general formula CH. Other than being of members of the same series. Okay, so this one, you need to know the properties of alkanes, okay? Which is actually these saturated hydrocarbons. So we do know that one characteristic is that they have similar chemical properties. This is true for all alkanes. It's in your alkane chapter, okay? So the second one will be, it has the same functional group, which is the alkane chain, right? And then we also have the trend, which is where n increases by 1, 2, 3, etc. to form different alkanes. So there is this trend of each consecutive member differing by CH2, because when you increase by 1, you notice that this CH2 will increase as well. Okay. So now for D, the last question, when 1 mole of chlorine reacts with 1 mole of propane, a mixture of 2 structural isomers is formed in the first step of substitution. Okay, recalling what is isomer. Isomers are the molecules with the same molecular formula, but they have different structure, okay? So let's draw this out. 1 mole of chlorine reacting with 1 mole of propane. Okay, we know that propane is this. Okay, it has 3 carbon molecules, and we draw the whole thing out like this, and then chlorine is here. So this is a substitution reaction, right, where one of the H is replaced by a Cl. So let's draw this. And then I will replace one of these hydrogen with a chlorine, okay? And since the chlorine is on the first carbon atom, let's take this as the first carbon atom. We'll name it 1-chloropropane. Chloro for chlorine, and it's on carbon 1, and then with the name of the straight chain alkane, which is propane. Let's draw the other molecule. Next, I want to replace this one with chlorine, this hydrogen with chlorine. So let's put it on the second one, and it's on the second carbon, so we have 2-chloropropane. 2 because it's on the second carbon, and chloro as the short name for chlorine, and it's attached to this atom here. So there you have it, and now it's the end of the paper.